Hi, I'm Josh Friell. I'm a PhD student in the Turfgrass Research Group here at the University of Minnesota. The research I'll be sharing with you today is part of a project run by the University of Minnesota and the Minnesota Department of Transportation and funded by the local Roads Research Board. And the objective is to identify mixtures of turfgrass that have salt tolerance and can be used on roadsides in Minnesota. The use of turfgrass on roadsides is beneficial for a number of reasons, including improved water quality, reduced erosion, and they can trap contaminants exiting the roadway. Of course, like any other roadside vegetation, it's necessary that they can withstand the wide range of concurrent stresses that are experienced in such an extreme environment. Now, the best way to approach this is to plant mixtures of grass that can exploit the superior characteristics of each species in order to withstand this wide range of stresses, which might include salt, drought, heat, ice, and so on. During the first phase of our project, we planted 75 cultivars of turfgrass split between 14 species at 3 locations around the Twin Cities metro area. And as you can see, we've already been able to identify differences between those cultivars and between the species. Such as this plot here, which is alkali grass. We identified this as being highly salt tolerant, but as you can see, it's not able to withstand the heat and drought of summer. On the other hand, this plot here is a species of fine fescue, and as you can see, it's done quite well both with the salt and with the heat and drought. So what you see here is one of our field sites for phase 2 of our project, in which we've taken the best performing cultivars from each species in phase 1 and mixed them together in different proportions to help provide different responses for each mixture. Now, each of these mixes contains between 3 and 6 of those species, with a maximum of 40% for any given species. Now, it's the overall ratios and proportions of those species that help determine the overall performance of the mix, and as you can see, we're already seeing large differences in those performances, such as in this plot, which contains a high proportion of fine fescue, versus this plot, which contains a higher proportion of tall fescue. In total, we've planted 51 mixtures of these turf grasses at 3 locations. At each location, the plots have been replicated 3 times, and using methods designed for mixture experiment analysis, we'll be able to identify the optimal mixture and the ideal proportions of each species to be used in a turf grass mixture for roadsides, which provides both sustainability and functionality. Thank you for listening. Again, I'm Josh Friell with the University of Minnesota Turfgrass Research Group.